Alright guys, today we're going to start section 2.2 here in Pre-Calc 20. What we're going to be doing is we're going to be looking at trigonomic ratios of any angle, okay? So what we'll be determining is the sine, cosine, and tangent of not every angle, but of certain angles that we already can know how to work with to solve for something within a Cartesian plane, okay? So to get started here, to find any angle on a Cartesian plane in standard position, we're point P, and that's given with the coordinates x and y here. It's on the terminal arm. What we can do is we can determine the distance that that point is from the origin, and then we can use Pythagoras' theorem to solve for side r. Okay, so that might be a little confusing at first, so let me break it down here for you guys. Um, so if you have some point on your Cartesian plane, let's say it's here. Why isn't that working? All right, I think we got it solved here. So you have a point on your Cartesian plane. That's right there, P. All right, now remember this is your x-axis and this is your y-axis. You're going to have point P, and the coordinates are going to be at x and y, right? So we can calculate the distance there. We call that distance to the point r. Now remember, when you're dealing with everything on a Cartesian plane, you got these distances here. This is your y, and this is your x value. And it makes a nice right triangle. So if you wanted to find the distance from the origin to the point on your Cartesian plane, here on your terminal arm, you can find that using r squared equals x squared plus y squared. Okay, and that'll give you the distance r using Pythagoras' theorem. So this here's your angle in standard position there. So knowing that, we can find r values for sine, cosine, and tangent, okay? Because remember, if we're dealing with this angle here, remember if we go back to SOHCAHTOA, just erase some of this stuff. I don't know why it's showing up. If we go back to SOHCAHTOA, though, we know that sine of any angle, right, is opposite. And if you look here on your triangle, my opposite would be y. And my hypotenuse now is r. Okay, and for cosine of my angle, it's adjacent, which would be my x value over r. And then for tangent, it's just going to be opposite, which is my y value, over adjacent, which is x. So tangent would be y over x. Okay, so if you have these coordinates, if you have your x and y coordinates, you can find any angle you want. All right, which is really nice. Now what gets a little tricky is, or what's, I don't know if it's tricky or it's nice to know, if you're dealing with your different quadrants, let's say we got quadrant 1, quadrant 2, down here we have quadrant 3, and over here we have quadrant 4, right? So with these quadrants, what you have to remember is, when dealing in different quadrants, your x and y values are going to change in value, right? So let's say we have, in quadrant 2 here, I have some point here at P. I know my P values. I know in quadrant 2, my x values are negative. My y values are still positive. All right, in quadrant 3, my P values, both x and y, are going to be negative. And then finally in quadrant 4, my P values, x is positive, but y is negative. All right, so if you have your negative x and y values at certain quadrants, what that's going to do is that's going to make your sine, cosine, or tangent values negative. So here in quadrant 2, when I'm dealing with that, I can see that anything that deals with the value x is going to make it negative. So I can see that here, sine is positive, cosine is negative, and tangent will be negative. Okay, all because my x value is negative in that quadrant. Now, when I'm dealing with quadrant 3, everything that deals with x and y independently will be negative. So sine's negative. Ooh, why is it doing this? Let's try that again. So sine is negative. Oh. Sine's negative. Cosine's negative. Now, if you look, tangent is x over y. So if I have a negative over a negative, that's going to mean tangent is positive. And then I can say the same here. When I do quadrant 4, I can see that all my y values are going to be negative. So I can see that sine is going to be negative. Cosine here is going to be positive, and tangent will be negative. So when you look at these, there's a little acronym that you could use to remember this, is that in quadrant 1, everything is positive, okay? Sine, cosine, and tangent are all positive. Quadrant 2, sine's positive. Quadrant 3, tangent, and in quadrant 4, it's cosine. So to remember that, there's a little acronym that you can use. So in quadrant 1, all are positive. In quadrant 2, sine is positive. In quadrant 3, tangent's positive. And in quadrant 4, cosine's positive. So another way to remember that is all students take cookies. Okay? So to remember these, it's pretty important because it'll give you certain clues about if something's positive in one quadrant, if something's positive and one's negative, you can kind of determine which quadrant you could be in or possibilities for that. So we can use this information now to solve different things. Okay? So make sure you take this all down, pause it if you need to, and then we'll move on to the next example. And we'll show you guys how to solve for r and different sine and cosine values. And things like which quadrant you are in will matter. All right, so write the trig ratio angles for an angle given at point P at -8 and 15. It lies on the terminal arm in standard position. Okay, so all that's saying is you're going to draw an angle off of point P and you're going to determine the trig ratios, okay, for this point. So we know our points at -8 and 15. So that means my x value is negative, my y value is positive. So I'm over here in quadrant 2. Okay, so I have my points at -8 and 15. Now these are just sketches. Sorry, I don't know why it's changing color like this, but that doesn't really matter here. So what we want to do is we want to find the trig ratios for this angle here, okay? So now to do that, I have my x and y, but I also need my r value. That's unknown. And remember, so this would be 15, and this would be -8. So with that, I can find r using Pythagoras. So r squared equals x squared plus y squared. Sorry that's so messy, guys. I don't know what's going on here. Either way, we can power through. R squared equals -8 squared plus 15 squared. So that's going to break down to 64. Remember, when you square a negative number on your calculator, unless you're using the proper brackets, it's going to make it negative. You just automatically make it positive. 15 squared is 225, right? Add these together. So that's going to be 289, and that's for r squared. So then you take the square root of everything, and r would be, and that would make r 17. All right, so there's no units given here because we're on a Cartesian plane, so it's not like 17 centimeters or anything like that. So now we have our r value, our x value, and our y value. So now we can solve for anything to get this angle here. So let's get going here. Now, if you're wondering, wait, we're finding an angle outside of the triangle? Well, what's nice about the Cartesian plane is this here would be my reference angle, right? We talked about those the other day. It's the smallest angle, it's the acute angle off of the x-axis. So what's nice about solving for trig ratios on a Cartesian plane is that the angle off in standard position will equal the reference angle, okay? All right, so these two angles are equal, and that's important. So I can solve for my reference angle, and it's still going to give me the same value, okay? And that'll be important because once we start getting into bigger angles, you'll need to use the smaller angles that we know, because right now we only know the angles of 3 triangles, right? Or of 3 angles, 30, 60, and 45. So we can go back and do this now if we use the smaller angles that we know. All right, so remember, sine was opposite over hypotenuse. So sine of my angle, this is a real pain. Sine equals opposite over hypotenuse. Cosine equals adjacent, so negative 8 over 17. And tangent equals opposite over adjacent. So we look, here are my ratios. If they're fractions like this, leave them as a fraction. I don't want them as a decimal. If you can, simplify the fraction as much as possible. Otherwise, leave it as is. So if we look here, sine's positive, cosine's negative, and tangent's negative, which makes sense because we're in quadrant 2, and remember, in quadrant 2, we're at S. It should be positive, so we know we've done this one right. Okay, now, I would like you guys to pause the video and try your turn here. I'm giving you the points at -5 and -2. It's on the terminal arm, so I would like you guys to figure out all 3 trig ratios for this one. I'll put the answer up here in a minute, but give it a go yourself. All right, so now if we look, here's what I got. I got my radius to be 13. So then my sine values were just -12 over 13. Cosine was -5 over 13. And then tangent was -12 over -5, which makes it +12 over 5, which makes sense because in quadrant 3, remember, it's the t value. Okay, so tangent is positive. All right, so hopefully you got all that. All right, let's move on to example 2. Here we're given the exact value. We want to determine the exact value of cosine at 135 degrees. Okay, so 135 degrees, if we draw that in standard position, my terminal arm is over here. I know that this is 135 degrees here. So now what I need to do is I need to determine what cosine is. And remember, cosine equals, it's my x value over r. So I need to find x and r. Now, easier said than done. So what you need to remember now, though, is I mentioned this up in the first example, that theta for any angle on my Cartesian plane, any values for anything, so cosine, sine, cosine of my angle will also equal cosine of my reference angle. Okay? Now I know if this is 135 degrees, 180 minus 35, that makes this 45 degrees. Sorry it's so messy, guys. But so that means cosine 135 equals cosine 45. All right, so now I just need to go back and think of my special triangles. And if I'm dealing with a 45 triangle, I know my ratios are 1, 1, root 2. So no matter what, I can simplify this guy down over here to anything that I need using this handy triangle right here. So now all I'll do is I'll just go cosine equals x over r. So cosine 135 just equals my x value 1 over root 2. And that's my answer. All right, so I need to remember my triangles here, those two triangles that I showed you guys the other day to solve this stuff. All right. Okay, next example. Suppose an angle is in standard position with the terminal arm in quadrant 3, and cosine equals negative 3 over 4. What are the exact values of sine and tangent for the angle? So we're not looking for the angle itself, we're looking for the values of sine and tangent based off knowing cosine. Okay, so we know this is in quadrant 3, which is this guy here. So we know that cosine equals negative 3 over 4. Now remember, cosine is x over r. So if I draw my terminal arm coming off, I know, that's bad. Let's try this again. All right, if I have this triangle, there's my 90 degrees, I know my x value is negative 3, and I know my r value is 4. Try that again. All right, just so you guys are aware, r is always going to be positive. Just because it's a length and we're using the Pythagoras, it'll always come out positive. So you'll never have a negative r value when dealing with these things. All right, only x and y can be negative. And because we're in quadrant 3, we know that y is going to be negative as well. Even though we're probably going to solve for it and it'll come out positive, in the end, it will be negative just based on the quadrant that we're in. So first thing I'm going to do is I'm going to solve for my y value because I need that for both sine and tangent. Okay, so I'm going to do that over here using Pythagoras. Yeah, now when you're using Pythagoras, things will come out. Oh, this is frustrating. Things will come out positive, even though they should be negative, just because we're squaring things and we're actually determining actual lengths. You can't have a negative length, but you can once you positioned it on the Cartesian plane. So r squared, that's 4 squared, equals negative 3 squared plus y squared. So that's just going to be 16 equals 9 plus y squared. So I'm going to bring the 16 over through subtraction. So 16 take away 9, that leaves me with 7. So that means my y value is radical 7. Just leave it like that. If you can't simplify it down, if you can't take an actual square root, leave it as a radical. It's fine, okay? So now all I need to do now is just solve for sine and cosine. So remember, sine is y over r. And so my y value here, remember, is going to be negative because I'm in quadrant 3, so negative root 7 all over 4. And then tangent, oh sorry, quadrant 3 here. So tangent in quadrant 3 is opposite over adjacent. So that's going to be negative root 7 over negative 3, which makes it positive root 7 over 3. Okay? So hopefully I'm not going too fast here. So if you need to pause the video and take this down, go for it. Next, I'm going to get you guys to try the your turn. You want to determine the exact values of sine and cosine if tangent is 1 over 5 and it's located in quadrant 3 as well. Okay? So pause the video, write down the notes, give that one a try, and then I'll put the answer up here right away. Okay, so here's what I got. I just drew it out real quick. Now when I found r, I took the square root of 26. Now I can't factor 26 down or simplify the radical by any stretch, so I just leave it as root 26. That's fine. And then I just put these as fractions, one over the other as a ratio, and I leave it there. Okay, so these are the values you should have got, hopefully. If not, maybe go back and double check. So that's what I'm going to leave you guys with today. For the lesson, if you guys could go to page 96 in the textbook, okay, and do questions. So page 96, do questions 1, 2, 3, 5, 6, and 8. Okay, those are the ones to do today. I'll go over examples 4 and 5 tomorrow in class, but this should be a good start for you guys. If you have any questions, don't be afraid to ask. Otherwise, good luck. And remember, the big thing to take away from all this is that your sine values, remember, are all just going to be x over y, right? Or y over x, or x over r, okay? So remember, you find your r through Pythagoras. And don't forget with example 1 here, or sorry, was it example 2 that I did? Yeah, example 2, if you're finding the value of an angle, and we've never worked with 135, don't be afraid to use the reference angle, because the trig value of any angle is equal to the trig value of its reference angle. Okay? So just work with those values there, okay? Oh, you know what? This is cosine. It's in quadrant 2. And remember, quadrant 2, sine is positive, so this should be negative 1 over. Oh, sorry. That should be a negative value. I'll go back. There. Okay? So yeah, because I'm in quadrant 2, cosine's negative. Ooh, it's a good thing I went back. All right. So good luck, guys.